This exercise will illustrate how to find out the probability of type 1 error alpha and probability of type 2 error beta and the power of the test 1 minus beta. Let P be the probability that a coin will fall head in a single toss in order to test H naught P equal to half. The null hypothesis is, here the null hypothesis is P equal to half. Against the alternative H1 is P equal to 3 by 4 and the alternative is P equal to 3 by 4. It is a simple hypothesis because the alternative hypothesis specify the value of P as 3 by 4 specific value, not it is less than or greater than or less than equal to, greater than equal to or not equal to. Since the specific value is represented by P in the alternative hypothesis, therefore it is a simple hypothesis. The coin is tossed 5 times and H naught is rejected if more than 3 heads are obtained. That is, the uh, coin which is tossed 5 times, the probability of getting 3 heads you have to find out. That PMF will give us the probability that there will be 3 heads. Now problem is to find the probability of type 1 error and power of the test. So here the S naught, which is the null hypothesis, P equal to half, and the alternative hypothesis is H1 P equal to 3 by 4. Now we associate a random variable x which denotes the number of heads in n tosses of a coin. Then this x is a binomial variate with parameters n and p, so that probability that x takes the value small x, that means the probability that the number of success is x, small x, is given by ncx p to the power x q to the power 1 minus x or 1 minus p to the power n minus x, because q equal to 1 minus p. Since the number of tosses is 5, so probability that x takes the value x, that means number of successes is x, is that 5cx p to the power x 1 minus p to the power 5 minus x is n equal to 5. Now the critical region is, in according to the question, the number of tosses is less than, greater than or equal to 4 if 3 or more than 3 heads appears. That means more than 3 means it may be 4 heads or 5 heads, because maximum we can get in this experiment is 5 heads, because number of tosses is 5. Now more than 3 means 4 and 5. This is the critical region. If the number of tosses is 4, number of getting the head is 4 or 5, then this is the critical region. We have to reject the null hypothesis, and the acceptance region is W bar is equal to where x is smaller or equal to 3. Now the alpha is the probability of type 1 error, which is given by probability that x is greater than 4 under the null hypothesis. Hence, if x is greater than or equal to 4, then we reject the null hypothesis. So this is probability that x equal to 4, and in that case p equal to half, because under h naught the value of p is half, plus x equal to probability that x equal to 5, again here also p equal to half, because the under the null hypothesis the value of p is half. So p equal to probability x equal to 4 is 5c4 half to the power 4 p to the power 4 x q to the power n minus x, that means half to the power 5 minus 4. Again for probability that x equal to 5 is 5c5 half to the power 5, just simple binomial distribution. So here 5c4 is 1 and 5c4 is 5, then half to the power 5, 5 minus 4 is 1, so half to the power 5 if we combine it, and here it is 5c5 is 1 and this is half to the power 5. So you can take half to the power 5 common, or 5 1 5 half to the power 5 plus 1 half to the power 5. If we add it, it will get 6 into half to the power 5. So ultimately 3 by 16. That is probability of type 1 error, probability of type 1 error, which is alpha, is equal to 3 by 16. Next we will find the beta, which is the probability of type 2 error. So probability of type 2 is probability that x belongs to the acceptance region when h1 is true. So which is equal to 1 minus probability that the sample point belongs to the critical region when h1 is true, because probability that x belongs to the acceptance region is equal to 1 minus probability that x belongs to the critical region. So in this way you can write, because total the entire region is divided into two parts. One is critical region or rejection region, or the other part is acceptance region or non-critical region. So total, if we consider the probabilities, probability of w plus probability of w bar is equal to 1. So that's why you can write down probability of x belongs to w bar is 1 minus probability x belong to w, or the critical region. So in that case 1 minus, when it falls in the critical region, the value of x is 4 and 5, because if the values of x is number of success is 4 or 5, we reject the null hypothesis. But here the under the alternative hypothesis, the value of p will be under the alternative hypothesis. So 1 minus, this is 1 1, probability x equal to 4, where it is h1 under h1 under the alternative hypothesis. So value of p is 3 by 4 under the alternative hypothesis, plus x equal to 5, again the value of p is 3 by 4 under the alternative hypothesis. So 1 minus 5c4, 3 to the power 4, p is 3 to the power 4, this is 4, 5c4, p to the power x into 1 minus p, which is 1 minus 3 by 4 is 1 by 4. So to the power 5 minus 4 is 1, it is 5 minus 4 actually. Then 5c5, 3 to the power 4 to the power 5, and 1 by 4 to the power 0. So which is not written, because the value of 1 by 4 to the power 0 is equal to 1. So 1 minus, here 5c4 is 5, 3 by 4 to the power 4, again from here 3 by 4 to the power 5, 4 is taken as common. So 5 by 5 is 5 remains, and 1 by 4 remains here, plus 3 by 4, it will be equal to 1 by 1 minus, if we simplify it, it is 81 by 128, ultimately 47 by 128. So 1 minus, this is the value of beta, is the value of beta. So power of the test is 1 minus beta, 1 minus beta. So 1 minus 47 by 128, which is again this value 81 by 128. So probability of type 2 error beta is 47 by 28, 1 minus beta is 81 by 128, and alpha is, we have got as 3 by 16. So this is the solution of this problem.